Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and today we're going to be talking about reflections of functions. In this video, we'll break down horizontal and vertical reflections of functions. You'll learn how to create new graphs from an equation, as well as reflecting existing graphs. So let's get started with a Desmos demonstration. So here we have our function f of x, and it's equal to the square root of x. And you can already see it on the graph. So for reflections, there are two main reflections we're going to be performing. One of them is to reflect along the x-axis, so meaning we're flipping the graph upside down. And the other reflection is across the y-axis, so we're flipping the graph left and right. So let's see which one does what. So first, we have a negative sign that is outside the function f. So we can see what happened was the original graph got flipped upside down. So this is a reflection across the x-axis. Next, we're going to have the negative sign inside the function. So it's beside the x. And what that's going to do is it's going to flip the original graph over the y-axis. So it's going to flip it over to the other side. So that's a left and right reflection. So let's take a look at another example. Okay, so here we have our parabola, which is x minus 3 times x minus 2. Okay, so this is the original graph. So again, we're going to do the same thing. If we try to reflect it by putting the negative sign outside the function, what it's going to do is it's going to flip upside down. So it'll flip over the x-axis. And if we put the negative sign inside the function beside the x, then it's going to flip our original graph over to the other side. So left and right, meaning this is now reflecting over the y-axis. So now let's do a quick recap of what we have just learned. If we have f of negative x, that is going to be a reflection over the y-axis, even though the negative sign is beside the x. And the reason is because it's all the x values that are changing signs. So that means it's a left-right flip, so a reflection over the y-axis. And similarly, if we have negative f of x, where the negative is outside, that is going to be a reflection over the x-axis because the y values are changing signs. Now let's take a look at this example here. So here we have our function g of x, and we've graphed it on this first chart. So we want to find g of negative x, negative g of x, and negative g of negative x. So let's draw each of them separately. So the first one is going to be g of negative x. So that is going to be reflection over the y-axis. So the x values are changing signs. So you can either take this original graph and visualize what's going to look like if you flip it over the y-axis, or you can take these 3 points and you can go ahead and change the x value to the opposite sign. That's going to end up looking like here, here, and here. So now, if we connect those 3 dots, that is going to give us our g of negative x. The next one is going to be negative g of x. So negative g of x means the y values are changing signs. So we're flipping over the x-axis. So that means this point is going to stay on the x-axis. The point that used to be 0, 1 is now going to be 0, negative 1. And then the point here that was originally negative 1, negative 2 is now going to be negative 1, positive 2. So again, we can connect the dots, and that is going to give us our negative g of x. And finally, the last one is negative g of negative x. So that means the x values are changing signs and the y values are changing signs. So that means this point here was originally 2, 0. If we switch the signs of both the x and y value, that's going to give us -2, 0. Now this point is 0, 1, and that's going to become 0, -1. And then this last point here was -1, -2. That is now going to become 1, 2. So all the way up here. So if we connect the dots, that is going to give us our negative g of -x. Now let's take a look at another example. But this time, instead of graphing the function, we're just going to find the expressions for them. So we start with our function f of x, and it's equal to the absolute value of x plus 3. And then we have our g of x, which is 1 over x minus 2. Okay, so let's go ahead and find this first expression, which is negative f of x. Okay, so negative f of x, and that is going to equal, well, f of x is the absolute value of x plus 3. So negative f of x would just mean that we have a negative sign in front, and then we have the absolute value of x plus 3. And then we have f of negative x. So what this means is for our function f of x, we're going to replace every x with negative x. So meaning f of negative x is going to be the absolute value of negative x plus 3. Okay, and the next thing that we need to find is negative g of x. Okay, so g of x is 1 over x minus 2. So negative g of x is going to be the negative of that entire thing. Okay, so you want to put a bracket after the negative. So it's going to be negative, and then we're going to have a bracket, 1 over x minus 2. And then you can go ahead and distribute this negative. So it becomes negative 1 over x plus 2. Finally, the last expression is going to be for g of negative x. So to find that, again, all we need to do is replace all the x's with negative x. So this becomes 1 over negative x minus 2. And then if you want, you can pull that negative sign in front of the fraction, so it becomes negative 1 over x minus 2. And those are going to be your 4 expressions. Okay, so let's go ahead and do a recap. So again, if the negative sign is inside the function, so meaning the negative sign is with the x, then what's going to happen is the graph will be reflected over the y-axis. And if your negative sign is outside the function, then the graph is going to be reflected over the x-axis. Because if it's outside the function, you're changing the sign for all the y values. So it's a up-down reflection, which means it's reflecting over the x-axis. Okay, so now, using this knowledge, can you find the solution to this problem? So if we have the point 2, -3, which is on the graph y is equal to f of x, where would that point move to on the graph y is equal to negative f of x? And where would it be on the graph if we have y is equal to f of negative x? Leave your answer in the comments below and let us know if you'd like to see more content on reflection in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.